Carry a compact weapon, and you sacrifice range and stopping power. Mount a heavy gun, and you lose mobility entirely. Scale up to naval autocannon, and you need a ship to move it. Every firearm in military service exists at a specific point on that trade-off curve, and moving in any direction costs something real. The fundamental tension in military armament is not between good and bad options. It is between competing operational demands that cannot be satisfied simultaneously. A personal defense weapon that fits inside a vehicle also cannot suppress a tree line at 800 meters. A rotary cannon that fires 6,000 rounds per minute requires electrical power, a mounting platform, and a logistics chain that no individual soldier can carry. The gap between those two realities is where most military firearms actually live. This breakdown covers 8 weapons across that full spectrum, from the 50-round bullpup PDW, designed to defeat body armor at close range, to the 25mm naval autocannon, built to stop fast attack craft before they reach the hull. Each weapon solves a specific problem. Each solution creates a new constraint. Understanding what each system actually trades away is more useful than ranking them by firepower alone, because firepower without context is just noise. The mission determines the machine, and the machine always costs something. The FNP-90 defines the personal defense weapon class through a radical departure from traditional submachine gun architecture. It utilizes the proprietary 5.7 by 28mm cartridge, a high-velocity round specifically engineered to bridge the gap between pistol and rifle performance. The weapon is built around a compact bullpup chassis with an overall length of just 500mm, yet it retains a 263mm barrel to maximize muzzle velocity. Its most distinct feature is the top-mounted translucent 50-round magazine. This horizontal feeding system allows for a high volume of fire without the ergonomic bulk of a traditional vertical magazine, keeping the profile slim for tight spaces. The performance implications of this system are centered on terminal ballistics and recoil management. Unlike the 9mm parabellum used in standard submachine guns, the 5.7mm projectile is designed to defeat soft body armor at ranges up to 200 meters. Because the cartridge is smaller and lighter than traditional pistol rounds, the P90 achieves a rate of fire of 900 rounds per minute with significantly less felt recoil. This allows operators to maintain high accuracy during rapid strings of fire. The downward ejection port makes the weapon fully ambidextrous, ensuring that spent casings do not interfere with the shooter's line of sight or become a hazard in enclosed environments like vehicles or narrow hallways. In practical application, the P90 serves specialized roles where concealment and penetration are non-negotiable. It is the primary choice for the United States Secret Service and various international counterterrorism units like the French GIGN. The trade-off for this specialized capability is the reliance on proprietary ammunition, which is more expensive and less available than standard NATO calibers. However, for vehicle crews and executive protection details, the value lies in having rifle-like lethality against armored threats in a package no larger than a traditional submachine gun. While the P90 offers a high-capacity integrated solution for armor penetration, other designs prioritize modularity and a more traditional handling profile to achieve similar ballistic goals. The Heckler & Koch MP7 represents the alternative engineering philosophy within the personal defense weapon category. While the P90 utilizes a high-capacity top-loading mechanism, the MP7 employs a more conventional, compact submachine gun layout. It is chambered for the specialized 4.6 by 30mm cartridge, a round engineered specifically to penetrate modern body armor that would typically stop standard 9mm projectiles. The weapon features a retractable stock and a folding forward grip, allowing the operator to transition from a concealed pistol-sized carry to a shoulder-fired carbine configuration in seconds. The performance implications of this design are defined by its high-velocity, small-caliber ballistics and extreme rate of fire. The MP7 cycles at 950 rounds per minute, delivering a high density of fire that compensates for the smaller diameter of the individual projectiles. Because the 4.6mm round is exceptionally lightweight and generates minimal recoil, the platform remains controllable, even during sustained automatic fire. The weapon's effective range of 200 meters matches the performance of many full-sized submachine guns, yet it maintains an overall length of only 638 millimeters, with the stock extended. This creates a distinct advantage for operators who must navigate confined spaces while retaining the ability to engage armored targets at distance. In practical use, the MP7 is the weapon of choice for specialized military and law enforcement units across Germany, France, and Japan, among others. It serves as a secondary sidearm for personnel who require more reach and penetration than a handgun provides, without the weight and bulk of a full-length rifle. The trade-off for this capability is the reliance on proprietary ammunition and a complex internal system that demands rigorous maintenance to ensure reliability. For units tasked with high-stakes close-quarters operations, the value of the MP7 lies in its ability to bridge the gap between pistol-caliber maneuverability and rifle-level armor penetration. This specialized focus on lethality against protected targets sets the stage for comparing such modern, high-tech solutions against the enduring, battle-proven legacy of traditional, high-caliber submachine guns. Transitioning from the specialized armor-piercing capabilities of modern personal defense weapons, the Heckler & Koch MP5 represents the enduring gold standard of traditional submachine gun design. Introduced in 1966, this German-engineered firearm quickly established itself as a global benchmark, chambered primarily in the widely available 9x19mm parabellum. Its defining characteristic is the roller-delayed blowback operating system, a mechanism that significantly reduces felt recoil and enhances accuracy, allowing for exceptional controllability even during sustained automatic fire. The performance implications of the MP5's design are evident in its balance of firepower and precision. With a rate of fire around 900 rounds per minute, it delivers a high volume of fire, while its 200-meter effective range ensures engagement capability in most urban and close-quarters environments. Unlike the high-velocity, small-caliber PDWs, the MP5 leverages the proven terminal ballistics of the 9mm round against unarmored threats, a critical factor for law enforcement and military units. Its robust construction and ergonomic layout further contribute to its reputation for reliability and ease of use, minimizing training overhead. In practical application, the MP5's global adoption by countless police units, armed forces, and special operations groups underscores its unparalleled versatility and effectiveness. It remains a favored choice for close-quarters battle due to its compact size, inherent accuracy, and the widespread availability of its ammunition. While newer designs offer different advantages, the MP5's legacy as a dependable, accurate, and highly adaptable submachine gun for a broad spectrum of tactical scenarios continues to influence firearm development, proving that foundational engineering can sustain relevance for decades. This enduring utility contrasts sharply with the utilitarian yet equally iconic designs that prioritized rugged simplicity over refined mechanics. The Uzi, introduced in 1950 and designed by Major Uziel Gal, represents the antithesis of modern, refined submachine gun engineering. Unlike the precision-focused, roller-delayed systems of its contemporaries, the Uzi utilizes a simple, rugged blowback operation. It is chambered primarily in 9x19mm parabellum, though its design accommodates diverse calibers including 45 ACP, 41 Action Express, and even 22 long rifle. With an overall length of 650 millimeters when the stock is extended, and a barrel length of 260 millimeters, it remains a compact, utilitarian platform. Its rate of fire is a modest 600 rounds per minute, feeding from detachable box magazines with capacities ranging from 20 up to 50 rounds. The performance implications of the Uzi's design are rooted in its mechanical simplicity. The open-bolt operation, while reliable in harsh environments, introduces a significant mass shift during the firing cycle, which impacts sustained accuracy compared to closed-bolt systems. Its 200-meter effective range is standard for the class, yet the weapon's weight and less ergonomic boxy profile make it feel cumbersome when measured against the sleek, polymer-heavy designs of the 21st century. However, this lack of refinement is precisely why it persists. The Uzi was engineered for mass production and extreme durability, capable of functioning in conditions that would cause more delicate, high-tolerance firearms to seize. In practical use, the Uzi's global footprint, spanning service in nations from Iran and Thailand to Poland and the United States, is a testament to its historical impact. It served as the primary submachine gun for the Israel Defense Forces for decades, proving that a weapon does not need to be sophisticated to be effective. While modern operators have largely transitioned to platforms like the MP7 or P90 for specialized armor-piercing requirements, the Uzi remains an iconic example of mid-century industrial design. It offers a distinct value proposition, a combat-proven, reliable tool that prioritizes raw function over technological complexity. This legacy of ruggedness provides a stark contrast to the high-velocity, specialized systems that now dominate the modern battlefield, setting the stage for the transition toward even more extreme, high-volume firepower. Here is the M134 Minigun section. The rotary machine gun presents a fundamental engineering paradox. The faster a single barrel fires, the faster it overheats and fails. The M134 minigun solves that problem by eliminating the single barrel constraint entirely. Developed by General Electric and derived directly from the M61 Vulcan aircraft cannon, the M134 entered service in 1963. Its defining architecture is 6 rotating barrels driven by an external electrical motor. Each barrel fires in sequence, meaning any individual barrel discharges at only a fraction of the weapon's total output rate. That rotation also keeps each barrel in the airstream between firing cycles, providing continuous passive cooling. The result is a sustained rate of fire between 2,000 and 6,000 rounds per minute in 7.62 by 51 mm NATO, fed from belt magazines holding anywhere from 500 to 4,000 rounds. Effective range sits at 1,100 meters, with a maximum range extending to 3,600 meters. The system weighs 18 kilograms for the gun unit alone, which is relatively light given its output, but the external power requirement and the ammunition logistics of sustaining that fire rate make it a vehicle or aircraft-dependent system by necessity. The performance consequence of that architecture is qualitatively different from any other weapon in this lineup. The M134 does not suppress a target, it saturates a zone. At 6,000 rounds per minute, the weapon delivers 100 rounds per second across its beaten zone, creating a density of fire that makes cover functionally irrelevant against exposed infantry or light vehicles. The electrically driven mechanism also allows instantaneous start and stop, giving operators precise burst control despite the extreme rate. In practice, this means the M134 is mounted on helicopters, armored vehicles, ships, and fixed fortifications, never carried by a soldier. Its operational logic is area denial and rapid target saturation during high-speed engagements, particularly in close air support roles, where dwell time over a target is measured in seconds. The trade-off is absolute dependency on platform, power, and a supply chain capable of feeding its appetite. Where the submachine guns in this list trade firepower for portability, the minigun trades portability for a volume of fire nothing else in its caliber can match. The M2 Browning was designed in 1918. It is still in active service today. That single fact carries more weight than any performance specification. John Browning's design fires the 12.7 by 99 mm NATO cartridge at a rate of 450 to 600 rounds per minute. Effective range reaches 1,800 meters, with a maximum range of 6,800 meters. The gun itself weighs 38 kilograms, with an additional 20 kilograms for the mount. Feed is belt-driven, typically from 100 to 200 round belts. The M2A1 variant introduced a quick-change barrel system with fixed headspace and timing, resolving the most dangerous maintenance procedure of the original design, which required manual headspace adjustment between barrel swaps. The 12.7mm cartridge is what separates the M2 from general-purpose machine guns like the PKM. At 1,800 meters effective range, it does not merely suppress personnel. It defeats light armor, disables vehicle engines, and engages low-flying aircraft. The ammunition selection amplifies this. Armor-piercing, incendiary, and explosive rounds give operators the ability to switch threat response without changing platforms. No other weapon in this list offers that breadth of target coverage from a single mount. The trade-off is mass. Crew transport and emplacement are required, and sustained fire demands a dedicated logistics chain. In practice, the M2 has been mounted on vehicles, ships, aircraft, and fixed fortifications across every major conflict from World War II through current operations. That deployment record is not nostalgia. It reflects a design that solved the heavy support problem so completely that no successor has displaced it at scale. The Cord and other 12.7mm competitors exist, but the M2 remains the reference standard against which they are measured. Where the minigun delivers volume through mechanical speed, the M2 delivers reach and terminal effect through caliber and construction. For any force requiring a platform-mounted weapon capable of engaging personnel, light vehicles, and aircraft at extended range with a single system, the M2 Browning remains the default answer after more than a century of service. The PKM entered Soviet service in 1961, and its core design has remained essentially unchanged because the engineering solved the right problems from the start. Mikhail Kalashnikov applied the same gas-operated rotating bolt principles that define the AK platform to a belt-fed general-purpose machine gun. The result weighs 7 kilograms, lighter than the FN MAG and the MG3, both Western competitors in the same role. That weight difference is not marginal. An infantry squad carrying a PKM retains genuine mobility that heavier GPMGs compromise. The weapon feeds from 100 or 250 round belts and fires the 7.62 by 54mm rimmed cartridge at 800 rounds per minute. Effective range reaches 1,000 meters. Maximum range extends to 3,800 meters. The rimmed case geometry that complicates feeding in other designs is handled reliably here through a purpose-built feed system engineered around that specific cartridge from the outset. The performance consequence of that caliber and rate of fire is sustained suppressive capability against infantry and lightly armored vehicles at ranges where most submachine guns and personal defense weapons become irrelevant. The PKM operates full auto only, which reflects its designed purpose: area suppression and unit support, not precision single-shot fire. That constraint is a feature of the role, not a limitation of the design. Mounting options extend the platform further: bipod for prone infantry use, tripod for fixed defensive positions, and vehicle mounts for mobile fire support. Each configuration shifts the tactical function without requiring a different weapon system. In practice, the PKM appears in the inventories of former Soviet bloc militaries, current Russian forces, and a wide range of paramilitary organizations globally, precisely because it functions under conditions that defeat more complex systems. Dust, mud, temperature extremes, and minimal maintenance access are environments where the PKM's simplified construction holds an operational advantage over mechanically intricate alternatives. Where the M2 Browning dominates through caliber and the minigun through volume, the PKM occupies the infantry support role through a combination of adequate firepower, genuine portability, and documented durability. That combination makes it the next decision point. How does a specialized naval platform extend these principles into maritime defense? The Mark 38 machine gun system solves a specific naval problem: stopping fast-moving surface threats before they reach a ship's hull. At 25 millimeters, it fires the largest caliber of any weapon in this lineup, and that distinction is not cosmetic. The M242 Bushmaster cannon at the system's core fires 25 by 137 mm rounds at 200 rounds per minute in automatic mode, with single-shot and short-burst options available for ammunition conservation and accuracy control. Effective range reaches 2,500 meters. Maximum range extends to 6,800 meters. The feed system holds a 168-round belt magazine. The mount itself exceeds 1 metric ton, and the gun alone weighs 109 kilograms. This is not a portable weapon. It is a shipboard installation, and every design decision reflects that constraint. Jointly developed by BAE Systems and Rafael Advanced Defense Systems, the Mark 38 entered United States Navy service in 1986 and has since been upgraded through Mod 2 and Mod 3 variants, adding electro-optical fire control, improved stabilization, and full remote operation capability from a ship's control console. The performance consequence of that caliber and remote operation architecture is direct. A 25mm round carries enough energy to defeat small boat hulls, disable outboard engines, and destroy drone airframes at ranges where smaller caliber systems are still acquiring the target. The remote operation mode removes crew from the exposed deck during engagement, which matters when the threat is an armed fast attack craft or a drone swarm closing at speed. The system functions effectively in rough sea conditions, where stabilization hardware compensates for vessel motion and maintains firing accuracy. In practice, the Mark 38 is deployed across United States Navy destroyers, frigates, aircraft carriers, and patrol vessels, precisely because it covers the close-range defensive gap that larger naval guns cannot address economically. Where the M2 Browning handles ground-based anti-material roles, and the minigun saturates an area with volume, the Mark 38 applies precision and caliber to a maritime threat envelope that demands both. The mission dictates the machine, and this system was built for one mission with no compromise on that requirement. The initial dilemma remains. Every weapon system, from the most compact personal defense weapon to the heaviest naval autocannon, embodies inherent trade-offs. There is no single best firearm, only the most effective tool for a specific operational context. Mission parameters, environmental factors, and tactical requirements dictate selection. This constant evolution and specialization in military armament means each design occupies a critical, often compromised, niche. Ultimately, the true measure of a weapon's value lies not in its raw power, but in its precise fit for the task at hand, acknowledging the costs involved in every choice.